All right, gang. Here's a couple examples on what's called the box method, which is an organizational technique for factoring these trinomials that have a number other than 1 here. So for like this example, a is 3. So that just kind of changes what must be the two factors because we have this number in front of the p squared. So it kind of makes it a little bit different than the ones that we've been working on for the last couple of days. So in the box method, you'll see me make what kind of looks like a plus sign. The examples in the note packet actually close it in as a box, but it will just look something like this, a plus sign for me. And when we're organizing this, we put things in certain spots. So this upper left spot, we put the quadratic term. So I'm just going to write quad here, and that is this term, or in this case, the 3p squared is going to go in that left corner. And then down here, we put the constant, nt. So for this problem, that would be the -5. Now, somewhere off to the side, you need to multiply these two as well. So we take that quadratic term, and we multiply it by the constant. So we take that off to the side. So for this example, I would take 3p squared, and I multiply it by the -5, and I get -15p squared. In the notes, that is what they're referencing with finding factors of a times c. So you may see a times c, but that's our quadratic term, and that's our constant that we're multiplying. So this is the piece, kind of like in the ones we've been doing the last couple of days, is that we want to find factors of this -15p squared that have a sum of that middle term, -2. So if I look at this, I'm thinking, okay, 15, I got 1 and 15, that doesn't work. 3 and 5, okay, that's good. 3 times 5 gives me 15. And 3 and 5 have a difference of 2. So again, this is negative, so we know one's going to have to be positive and one's going to have to be negative. So I'm going to have a -5p and a +3p. If I multiply those together, I get this -15p squared that comes from the quadratic term times the constant. And if I were to add these together, -5p plus 3p gives me the -2p, which matches my linear term in my trinomial. So now what do I do with these? These two pieces are what you put in the other corners of the quote-unquote box. And it doesn't matter where you put the -5p or where you put the 3p. So I'm going to put -5p here and the 3p here. Okay, so that's what it takes to set up this box. Now, when we use this structure to help us factor, we need to look at what's the GCF for each row going across and each column going up and down. So when I look at the GCF for this top row, okay, I got 3p squared and -5p. The only thing that these two terms have in common is a p. And then when I look at the bottom row, and I look for the GCF in this row, 3p and -5, they don't have anything in common. So it's at least a 1. So those are the GCFs for the top row, p, and the bottom row, 1. And then I look for the GCF for each column. So when I look at this column, 3p squared and 3p, I see that they have a 3 in common and a p. And then when I look at this column, I see a negative 5p and a negative 5. So I know that this column has a GCF of negative 5. When it comes to signs, whether it's positive or negative, you always take what would be the leading term. So as I'm going down, this negative 5p is the leading term. It's negative, so I would want to use negative there. Now these two pieces here on the columns and here on the rows are my two binomials that give me my factors. So one would be 3p minus 5, and the other one would be a p, and that's a positive 1, so plus 1. So that structure helps me factor this. And so now if I just kind of quick check, 3p times p gives me my 3p squared. 3p times 1, so I have a positive 3p. Negative 5 times p gives me a negative 5p, and negative 5 times 1 gives me the negative 5. So now I'm starting to see that structure, those pieces that I looked for from this quadratic times constant piece that I started the problem with. If I put those together, that's where I get my negative 2p, and then I have my constant negative 5 and 3p squared. So now just takes 30 seconds to quick check, did I get what I started with for my problem? Now this is my answer. These are my two binomial factors right here. Okay, so if I'm asked to factor this quadratic, this would be my answer. Okay. I'm going to do one more now. So that was the first example, kind of in the note packet. And here's the second one. I'm going to slide this up a little bit. So the second example is 2n squared plus 3n minus 9. Okay, so I make my box, in this case my plus, that's all I do. I write my quadratic term here. I write my constant down here, and then someplace off to the side I multiply those. And so I get negative 18n squared. And I want to find factors of this negative 18n squared that have a sum of this positive 3n. So I'll go, okay, so I want to have one be positive, one be negative. So I'm going to need a positive 6n and a negative 3n. If I multiply these two together, I get the negative 18n squared. And if I add them, I get the positive 3n that I need for this middle term, or my linear term. And again, I could put these in either spot. So I'm going to put this 6n here and the negative 3n there. And then I'm looking again for that GCF for each row. So I'm going to do the top row. GCF for 2n squared and 6n is 2n. And the GCF for the bottom row is negative 3. And then I do the GCF for each column. So 2, negative 3, nothing matches there. So it's just the n from the n squared in the n. And then I look at this, 6n, negative 9 is a positive 3. Again, I'm taking the leading term. So as I go down, 6n is the one I'm looking at first before the negative 9. So it's a positive 3. And then these two pairs make up my two binomials. So n plus 3, 2n minus 3. So these would be my factors that I'm looking for. And then just a quick check. N times 2n is 2n squared, so that's what we started with for our quadratic term. And then my last, positive 3, negative 3, so when I multiply those, I get my negative 9. And then if I check those other two terms, so 3n times 2n is 6n, and then the n times the negative 3 is a negative 3n. And when I add those together, 6n minus 3n, I get a positive 3n. Whoops, and running out of room. And that is the same as my linear term here. Okay, so there's a couple examples on the box method. We'll spend more time on this the next day as well, but this will hopefully give those of you that wrap up the quiz and are looking to move on a little bit of a head start.